Before we launch into this example, what I want to do first is to figure out how many degrees is in each one of these pockets. So we're going to be talking a lot today about the different different rotational angles, and we don't need to use a protractor because we can know on an isometric grid there are certain properties. So in this shape here, we have a 1, 2, 3, 4, 5, 6. So we have a hexagon, a regular hexagon actually. So in each triangle, we turn a certain amount. So if we were to have 6, that means that the order of rotation, okay, using new language that we just learned, the order of rotation for this specific triangle is 1, 1, 2, 3, 4, 5, 6. So if we want to figure out the angle of rotational symmetry, we're going to have 360 degrees divided by the order of rotation, and we said that the order of rotation of this is going to be 1, 2, 3, 4, 5, 6. 360 divided by, oh, not 6, but, oh yeah, no, actually by 6, yeah, by 6 is going to be 60 degrees. So each time, so I'm just going to erase this, from here to here is going to be 60 degrees. So we're going to be able to use this to our advantage because we're going to be determining what the angle of rotational symmetry is. So let's read that question. So determine which of the hexagons below have rotational symmetry. Now remember, a hexagon has 6 sides. Let's see, 1, 2, 3, 4, 5, 6. Yes. Now the hexagon that we made was a regular hexagon because all the sides were the exact same in length. But these are hexagons nonetheless because they will all have 6 sides. State the order of rotation and the angle of rotational symmetry. Okay. So here's how we would do this. I'm going to create a shape that repeats. So I'm going to draw my line right here. And I'm going to draw, just for kicks, I'm going to draw my line like this. If I were to rotate this shape around, it wouldn't fit perfectly. But if I change this line just a wee little bit, I have this shape and this shape, or this line and this line creating this shape right here. Can I create that shape again? Oh. If I go like this, this shape is the exact same as this shape, which is the exact same as this shape. So that means that the order of rotation for this is going to be 3. So since we know that the order of rotation is 30, let's find the angle of rotational symmetry. So I can do this one of 2 ways. I can use the equation, but first, just to make sure that we know what the just to see if the equation works, we would say from this line to this line, we would be moving one isometric triangle and another isometric triangle. Now we know that each one of this is 60. So 60 plus 60 is 120. So we already know that the answer is 120. So let's see if this works. We know that the angle of rotational symmetry is 360 divided by 3. 360 divided by 3, ding, ding, ding. That is simply 120 degrees. So we got it. Now this is also isometric. If it were not isometric, it would be in a grid pattern like this. But it's like the grid pattern has been rotated a little bit. So let's see what the order of rotational symmetry would be for this one. Now this one's weird. Okay, so if I go like this, I can create this shape like that. But if I were to rotate this shape 90 degrees, it would actually go a little bit taller. It would look like this. That's what this shape rotated 90 degrees is. So we know that the rotation is not a 90-degree rotation. If I draw this one here, now there are a few types of symmetry that are happening here. This could be a line of symmetry and a reflection line. So we could say that it has reflectional symmetry, but if I take this shape up top here, and if we twist it so that it goes onto the bottom here, order of rotation equals 2, because we have two of the exact same shape. If we swung it around this this central dot here, the rotation, we would be able to fit 2 of this shape in until the shape would coincide, or we would draw over this shape again. So that means that the angle of rotational symmetry that is going to be 360 divided by 2, which is 180. So the angle of rotational symmetry is 180, and it is the order of rotation is 2. What about this last one? Now, if I were to draw this right here, I would say, there's a repeated shape here. But if I took all of these shapes, and it's kind of similar in B, there could be a rotational symmetry of 180. What I could do here is I could draw on top of this. I could draw on top of this, and I could use my magic, and I can rotate this shape. I can rotate it 90 plus 90. Okay, so 90 plus 90 is 180. So if I would rotate the shape 180, I would bring it down. It would actually, if it had a rotational symmetry, it would actually look like this instead, because I've rotated 180 degrees. But instead, we have a shape that looks like this. So we have a reflection in this line of symmetry, but we don't actually have rotational symmetry, because if we did and rotated it 180 degrees, the shape would actually extend down like this. So we can simply say that this shape, so this hexagon, has no rotational symmetry. So it must be rotated 1 complete turn before it coincides with itself again. And remember, we cannot have order of rotation which is 1.